Every time ChatGPT answers you, it isn't writing whole sentences in one shot. It's predicting one word, then the next, each one shaped by everything it has already said. That single, almost stubbornly simple idea, generate one piece at a time, powers not just language models but image generators and speech synthesizers too. It turns the terrifying problem of modeling an entire sequence into a chain of tiny, manageable predictions. It is arguably the single most successful recipe in generative AI today. So how does predicting one element at a time add up to coherent paragraphs, images, and audio? Let's take it apart. So what's the big idea, and why not just generate everything in one go? Here's the contrast. Trying to produce an entire output in a single shot is genuinely hard. When every pixel or every word is emitted simultaneously, nothing coordinates them, and the pieces tend not to agree with each other. Getting a whole coherent sequence to fall out all at once, perfectly consistent, is a brutal modeling challenge. Coordinating thousands of pieces simultaneously is a genuine nightmare. An autoregressive model sidesteps the whole problem. Instead of everything at once, it generates one element at a time, and each new piece is conditioned on everything already produced. By always looking back at what came before, each step stays consistent with the last, and coherence emerges naturally, one prediction building on the previous one. Here's the mechanism step by step. Watch how a full sequence gets built from nothing but a run of small predictions. It starts by predicting the very first element from scratch, or from a prompt you provide. For text, that's the opening word. For audio, the first sample. For a PixelCNN image, the top left pixel. Just one small, self-contained prediction to get the chain going. Then comes the crucial move. That first element gets fed right back into the model as input, and now it predicts the second element, conditioned on the first. The output of one step becomes part of the input to the very next step. This repeats, and the context keeps growing. Every new element is predicted from all the elements before it, which is exactly the chain rule of probability in action, the whole sequence factored into a product of conditional predictions, each one a proper probability you can train on directly. Piece by piece, the full sequence assembles itself, a coherent paragraph, a clean image, a second of audio. This is how GPT writes text, PixelCNN paints images, and WaveNet generates speech, all the same loop. But notice the catch, each step waits on the one before, so generation is stubbornly sequential. Boil it down, and three ideas carry the whole paradigm. It builds a sequence element by element, each conditioned on the past. The probability of the whole factors by the chain rule into a product of conditionals, so a hard joint problem becomes a chain of easy next step predictions. It gives exact likelihoods and trains stably. Each conditional is a genuine probability, so you optimize with plain maximum likelihood, no adversarial game and no lower bound. Even better, training parallelizes. Causal masking lets every position be predicted at once. And it's the reigning champion of generative modeling. This single principle powers every large language model, plus PixelCNN for images and WaveNet for audio. Its one real weakness is speed, because each element waits on the previous. Generation can't be parallelized and slows on long outputs, though clever methods can speed it up. Alright, let's lock in the essentials. An autoregressive model generates data one element at a time, with each new piece conditioned on all the elements before it. By the chain rule, the sequence factors into a product of conditional probabilities, giving exact likelihoods and simple, stable maximum likelihood training. This single idea powers GPT for text, PixelCNN for images, and WaveNet for audio, and training parallelizes neatly with causal masking. Its defining trade-off is speed. Generation is sequential and slow for long outputs, and it needs a chosen order for the data. If you enjoy the ideas behind modern AI unpacked one clear piece at a time, Come explore more with us at standarity.com. See you there.